Alright, how's everybody doing out there in Math Magic Land? That's right, Miss Muscarella coming at you in this third and final video here of solving radical equations where you have a variable underneath two radicals. Not just one, but two. So let's go ahead and kind of analyze what this might look like a little bit. So you're going to have a radical, something like that, and you're going to have another radical, something like that. And you're going to have a variable underneath each one of them. Maybe you have a +3 or something, or maybe there's an equal sign in between them, or maybe you have something like this. Square root of x plus 3, and then like -5, and then equals another square root of, say, 2x or something like that. So you're going to have two different radicals that each have the same variable underneath it. And these couple examples, your variable, of course, is x, because that's what math people like to use the most. All right, so anyway, let's go ahead and take a look at our first example. Now check this one out. Every time you solve these, you're going to kind of take a look at these several steps here. You're going to separate the radical to opposite sides of the equal sign. So when we have this first one right here, square root of x plus 1 minus square root of x, or square root of 3x equals -1, you'll see that both radicals are on the same side. And we don't want that. We want them to be on opposite sides. So what we're going to do is add the square root of 3x to the other side. When you do that, that will look like this. And then, of course, from here, what you're going to do is take the x plus 1, that square root, and the square root of 3x minus 1, those two sides, and what you're going to do is undo the radical. And to undo that, what you're basically going to do is like boom, boom. To get rid of that, you're going to square that side, and you're going to square that side. So of course, in showing our work, some people will show it like that on that step right there, and other people might, just go ahead and do that. But that's all that's going to look like, just like that. Now, you have to be careful here, because one of the things you're going to notice is that on the square root of x plus 1 squared, so this and the square root, they're going to cancel out. They're going to be gone. All right, so you're just going to have an x plus 1 drop down on that left side. On the right side, all right, some people might be able to do this part in their head, and other people might need to take a few moments to a few steps to actually show this. So whichever the case is for you, I'd rather you take your time and show your work than, oops, make a careless mistake. So if you have the square root of 3x minus 1, that quantity squared, that means you, of course, would write that twice. Now, when you distribute that, again, some people are going to take more steps to do this than others. So if you use the distributive property correctly, so square root of 3 times square root of 3, that gives me my first term right here, and then square root of 3 times -1 gives me minus square root of 3x. And then if I have -1 times square root of 3x, that's going to give me this term, and then lastly, this guy right here, -1 times -1 gives me 1. Now again, some people might be able to do that step in their head and go right to this next part where you just combine these two guys. So what you could do is just say, hey, these guys here together end up giving me this -2 square root of 3x. All right, so either way you get there, some people might need to write it out, others might need to take a couple of steps, and some may be able to just do it all in one step in their head. But make sure you show that, and of course, make sure you keep your equal signs nice, neat, and organized in your mathematical writing. Now, after I've carefully undid that first radical, you'll notice I still have another term that's got a square root and another radical in it. So what I'm going to need to do here is actually take these two terms, these guys right here, this one, 3x, and the 1, and I'm going to need to get those to the other side. I'm going to need to get both of those to the other side. So it's going to kind of depend what you see. Some people, again, it's going to kind of depend on their steps. So if I move the 3x over first, I'll subtract 3x, and that will give me this -2x right here. And then some people, again, it just kind of depends what you see, but you may be able to say, hey, this one right here and this one right here, since I have the same term on both sides, I could cancel that out, and of course, then, that'll just be 0. So I'll end up with -2x equals -2 square root of 3x. Now again, I'm trying to solve for this variable. I mean, that's my goal right here. After all this kind of stuff is said and done, this guy right here, that's the one, we want to get x by itself. But notice, I got an x over here too. So I do end up wanting to solve for x. So first thing we're going to do is, just kind of undo our order of operations here. So we've got a -2 in front of the radical. So I would divide both sides by -2. And then, to get rid of the radical, of course, you're going to square both sides. When you square both sides, right, the square root's going to go away on the right side and just leave you with 3x. On the left side, you'll have x squared. Now this is going to end up being a quadratic to solve, so we'll move the 3x over to the left side and end up with the equation x squared minus 3x equals 0. And by now you should look at that and go, oh, All I got to do is factor. So the GCF of both terms is x, so you would factor out an x, and you'd have x times the quantity x minus 3 equals 0. And setting each one of them equal to 0 and solving for that, you guys can do that at this level. You would just end up with, boom, you get x equals 0, and then the other one, of course, would be x equals 3. So those are my two solutions. All right, now the very last thing, so I've solved for the variable. I've come up with two different pieces, and now what I need to do is actually check. I've got to check to see if one or both or neither of those two values that I came up with work. So my two solutions here that we're going to check is going to be x equals 0, and we'll check that one first. So of course, you write the word check because that's what you're doing. All right, so we're going to check the x equals 0 term first, and the very first thing you want to do, of course, is rewrite the original problem. Now what we want to do is come up with -1 on the left-hand side, because the only thing on the right-hand side is just that constant -1. So if we substitute in 0 for x, and again, some people may be able to do this step in your head, but if you need to, take your time and write it out. Don't try and rush just to be done. I'd rather you take your time and get it correct than make a mistake and then be salty because you got it wrong. All right, so here we go. 0 plus 1, of course, is 1, and 3 times 0 is 0, so you have the square root of 1 plus the square root of 0, and when you add those two terms together, but before you do that, of course, you should know that square root of 1 is just 1, and square root of 0 is 0, which just leaves us with 1 equals -1. What? No, that is not possible. That's not good. So -1, or x equals 0, sorry, x equals 0 is not one of my solutions. So x equals 0, you don't work. So that solution is what we call extraneous. So x equals 0, that one's extraneous. All right, and then my other term, so now I'm going to try the x equals 0 or x equals 3 term, and when we do that, of course, what I want you to do is write down x equals 3, because that way you're communicating to whoever is reading your work that that's the value of x that you're checking. So in the first one we wrote down x equals 0, then substituted in, and in the second value we're going to take a look at x equals 3. So again, write down the original problem, square root of x plus 1 minus square root of 3x equals -1, and then we'll just plug in our 3 for all of our x's. Now 3 plus 1 is 4, so I'll have the square root of 4 minus 3 times 3, which gives us 9, so square root of 4 minus square root of 9. Simplify both of those, we end up with 2 minus 3. And of course, we all know our arithmetic, and that does give us -1. So thank you very much. That is awesome. I love you, 3, because this guy works, which means -3 is my only solution. X equals 0 was extraneous. All right, so make sure you identify that x equals 3 is your solution and x equals 0 is extraneous, because in other math courses above Algebra 2, you will need to make sure that you identify both possible solutions and then which solution is extraneous and which one is correct. All right, so that's it for this example. Let's go ahead and take a look at one other example. All right, so here in example number 2, our second one of this type, where we have square roots on both sides, the very first step, of course, is to take a look at and make sure you have the square roots on different sides of the equation, which we do. Very nice. All right, so we don't have to move anything around. We're good. So you should remember, all right, so we're going to square both sides. So we'll square both sides, which is really nice, because then that means that square root of x plus 10 and the squared, both of these kind of, what they do is they end up canceling out. So that's gone, and the square root part is gone. So the only thing you're left with is just that x plus 10 on the left side. So that will drop down. Now again, different people can do different steps, but what I want you to do, if you need to write it out, so squared means we're going to write down that quantity x minus square root of x plus 6. We're going to write that down twice. And then when you distribute or FOIL, because a lot of times people will say FOIL, when you FOIL that or distribute that, you should correctly end up with 64 minus 8 square root of x minus 6 minus another 8 square root of x minus 6 plus. Now, this part right here, so just so you're okay with that, when you have square root of x minus 6 times square root of x minus 6, now notice both of these are negative, so that's why this term right here is positive, and then the part inside the square root, that's all you're left with right there. So just make sure you take your time when you do that, and be careful, because that's where a lot of people will make a mistake. All right, so take your time, inch by inch, it'll be a cinch. So here we go. Now let's clean this up. And of course, we'll combine our two middle terms with the radical, and that'll give us minus 16 square root of x minus 6. And some people may even be able to kind of work with this part and then say, hey, well, let me combine this guy right here with this minus 6 over here. And you could do that on that step. Or if you need to just take your time, do one step at a time, you can end up doing that however you want. But in either case, you'll end up with the 10 on the right-hand side equals 58. minus 16 square root of x minus 6. Now, where'd the x go? All right, so I'm glad you asked that. If you notice right here, we have an x, and over on this side, we have an x. So both of those guys would just kind of cancel out, which is why on the left-hand side there, you are just left with 10. Now, what we would do, of course, is we're going to take this 58 right here. We're going to take that 58, and this 58, what you're going to do is subtract that. So 58 here is going to move to the other side, and when that happens, you'll subtract 58 and end up with negative 48. And then on the right-hand side, you'll have negative 16 times the square root of the quantity x minus 6, and then divide both sides by negative 16, and we will end up with 3. Now, kind of went ahead and did two steps here, did two steps at once here. So we got 3, but then to get rid of the square root, of course you're going to square both sides, and when you square both sides, you will end up with 9 on the left-hand side, and then just the x minus 6 on the right-hand side. And then lastly, but not least, you move the 6 over, and of course that becomes 15. So we get a value for 15 as x, and then what we need to do is just make sure we check ourselves before we wreck ourselves. So again, with the check, take your time, one step at a time, write down the original problem. Then plug in 15 anywhere there's an x. Boom. 15 plus 10, of course, is 25, and 15 minus 6 is 9. So you'll end up with the square root of 25 equals 8 minus the square root of 9. And we all know the square root of 25 and the square root of 9 are both 5 and 3 respectively. So we'll end up with 5 equals 8 minus 3, which then leads us to 5 equals 5. Booyah, yes, that makes us happy because this value right here that we got, 15, so that's a check, that works, which means 15 is a solution. It's not extraneous. All right, so that is it for this video. I just want to give you guys a couple quick examples on solving square roots, or radical problems where you have a square root on both sides of the equal sign, and so that is how you do that. All right, thanks for watching, you guys. Have a great day, and I will catch up with you later. Peace out.